Okay, so we're going over polynomials. Nothing today is new, okay? So don't overthink anything today. Okay, so polynomials are just expressions okay, they're just expressions made up of one or more terms. Okay, and your terms, the best way to know your terms is they're separated by plus and minus signs. Okay, so we're going to talk about what the number of terms, what you call somebody, what you call an expression depending on how many number of terms there are. So if there's one term, we call that a monomial, because mono stands for one.
Oh, I remember this.
Okay, so two terms is a binomial.
Oh, and 3 is trinomial?
Three terms is trinomial. Oh, good. And then four, you didn't hear that? Four or more, there's no really special name for, so we just call those polynomials. Are we okay with that? Okay, so knowing that, how many terms does this have? 2, so what do we call it? A binomial. So the way I always tell, especially when there gets to be a lot, I always draw a little, like a little wall anytime I have a plus or a minus. And I always draw it in front of the plus or minus sign, because when we get to the back of our notes, we're going to actually be combining like terms. And if you draw this, you're not going to be able to see if it's plus or minus if you draw it right on top. Okay, so this is 2 terms, so we call this a binomial because it's 2 terms. So again, there's a plus, there's a minus, there's a minus, there's a plus. So we have 1, 2, 3, 4, 5. Do we have anything fancy to call something with 5 terms? No, so we just call it a polynomial. Any questions with that? Pretty simple? Okay, now we're going to look at degrees. So degrees and terms are 2 different things. Terms are just how many separated by plus or minus. Degrees are the sum of the exponents of the variables per term. Okay? So the term with the highest degree is the degree of that polynomial. So we're going to talk about what that means, but first we're going to talk about the fancy words for different degrees. So a degree of 0 is possible. That's when there's no letter, right? So it's just a constant. Oh, I was right about to write it in. Okay, if there's a degree of 1, it's linear. A degree of 2 is quadratic. A degree of 3 is cubic. And then 4 or more, again, I don't know why, but we always stop at 4. There's no fancy word, so you just write the number, which we'll do an example of. Okay, so knowing that, it says, what is the degree of this first expression? Well, again, I'm going to separate my terms. And the reason being is because, remember, we're looking per term. And we're going to add the exponents of the letters per term. So looking at this first term, what are my two? I have two variables. So what's 7 plus 4? 11. And what's 4 plus 5 on my second term? 9. Okay, so the one with the highest degree, which one's the highest?
The one on the
11 is your degree of that polynomial. So this is 11th degree.
what? This one. That's our answer?
Because that's all it's asking, is what the degree is. Okay, so let's look at example 4. Again, we're going to separate our terms. There's a term, there's a term, there's a term, there's a term. And we're going to write the degrees of each. Now, this has an x squared and a y. Remember, anytime there's not an exponent, what do we put there? A 1. That was one of our rules that we talked about the last couple days, right? So there's 2 plus 1. So this is a degree of 3. So this would be a degree of what?
2.
2, yeah, because 1 plus 1. Now this one is a degree of
2.
2. This is a degree of 1. And what's this a degree of?
1.
If there's no letter,
Constant.
it's 0. It's a constant. So if it was just 7, we would call it a constant because there's no variable. Does that make sense? Okay. So now, what's my highest degree?
3.
3. So what is this called?
Cubic.
Cubic. So now we're going to mix the two. And we're going to find the terms and the polynomials for these 4. Yes? So I always like to separate and then write my degrees above. So what's the degree of my first term? 2. Second term? 3. 1. 0. So what's my highest degree? 3. So what do we call it?
Cubic.
Cubic.
And trinomial?
Well, no, because 1, 2, 3, 4 terms. So it's a cubic polynomial. Now, if you wrote polynomial cubic, that's fine. I just think it sounds better to put the degree before the number of terms. Doesn't cubic polynomial sound better than polynomial cubic? It makes sense to my brain. Okay, so let's look at example 6. Now, this one's kind of a trick question.
Why?
What's the degree of that first term?
5?
No. Because we're only looking at the exponents of the variables.
Also just 3.
Yes, because we could rewrite this as 9x cubed. So this is just a degree of 3. Now what about the second term?
4.
A degree of 4. Because you only look at the exponents of the variables. So remember in our definition of a degree, it's the exponents of the variables. And that first one is 3 squared. That's not a variable. So the only variable is x. Therefore it's just 3. Does that make sense? And this is why. It's because you can rewrite it as 9x cubed. So this is a 4th degree because that's my highest. And how many terms are there? 2. So what do we call that? No. Look at the terms. Binomial.
Binomial.
You're mixing the two. That's okay. I know what you meant. Okay, so again, split my terms. What's the degree? 1 degree, 0, and how many terms?
1.
2. So what is this?
Linear binomial?
Linear binomial. Now the last one's kind of another trick one. What's anything times 0?
0.
So if I rewrote this as just 0, is it the same thing? So just look at this simplified version. What would you call that? A constant?
A constant.
Monomial.
Monomial.
Because there's only...
How do you get linear for number 7?
Because your highest degree is 1. Okay, when you're done writing that down, flip to the back. Okay, these first four on the back are super simple. You've done this as we called it function notation. Now they're just saying it's defining polynomial functions. It's the same exact thing. So I'm going to show you two different ways to do it. Both of them will get you the right answer. So the first way you can do it is, I say by hand, not really by hand, you're just going to plug it in on your own, is anytime, well first, this is p of x, which is just telling you it's a function, equals 3x squared minus 2x minus 5. So this is p, so it means I'm using that equation. Well, what did I replace on the inside of the parentheses?
Replace the variable.
Which was what?
X.
So I know that x equals 1. So I'm going to rewrite this equation, but instead of putting x, I'm going to put a 1. And every time I replace that x, I'm going to use parentheses just to make sure I don't mess anything up. And so, like I said by hand, but like not really. So like if you come here in your calculator, you're going to just type it 3 parentheses 1 squared minus 2 times 1 minus 5. And what do we get? Negative 4. So p of 1 equals negative 4. You can get that? Make sure you're typing minus and not negative.
I did it wrong.
Did you type negative?
I think
What happens is it'll multiply.
I got it.
Did you do this one?
That's the answer to that one?
Maybe. Okay, so try this one. Okay, when you're plugging in a negative, it's especially important to make sure you're using parentheses, because if you don't and you're squaring it, it's not going to square the negative properly.
I don't do parentheses.
Oh, yeah, you have to use parentheses. Type it literally exactly the way I wrote it.
Okay.
And what does that equal?
11.
Any questions with that?
I like this part.
Okay, I'm going to show you one other way to do these. You can do them all that way. Or if you're doing a bunch of them, this is actually an easier way to do it in my opinion. You're given the equation. It's telling you x equals 1, x equals negative 4. Can you put this in your y equals?
Mm-hmm.
Yeah, so if I go in my calculator and I go to my y equals, I can type the equation given to me, yes? Right?
Mm-hmm.
And then I can go to my table. Well, this is saying p is 1, or p of 1, which is x is 1, and what does that equal? 4, so there's my answer. And then this one's telling me negative 4, so if I come up here to negative 4, what does it equal? Negative 21. Does that make sense? So you can use your y equals, or you could just plug it in like that and put it in your calculator. Any questions with that part? Okay, last but not least is simplifying polynomials by combining like terms. So the last 3 days we've been multiplying and dividing exponents, right? But now we're adding things with exponents. Exponents do not change when you're adding or subtracting. The only thing that changes when you're adding or subtracting is coefficients. But the exponents and the variables have to match first. So that's what we mean by like terms. So like here, x squared, those are alike, so we could combine those, right? Y, those are alike, we combine those. A squared, B, those are alike, we could combine those, yes? Now, are x and y the same? No, so we could not combine those. X squared and x are also not the same, we could not combine those. ST squared and S squared T. Yes, they both have S and T, and yes, they both have a squared, but is the same letter squared. Therefore, they're not like terms. Does that make sense? Okay, so knowing that, are these like terms? So, can I combine them?
Yes.
And what's negative 3x plus 7x?
4.
4x. Now, if you want to type these in your calculator, you can, but you cannot type the x in your calculator. So you can only do negative 3 plus 7, and you just have to remember to put their variable back. Yes? Okay, so looking at B, what are your like terms? Yeah, so 11x squared is a like, and with 2x squared. What else is a like term?
5 and 7.
Yeah, positive 5 and negative 7. So we're going to combine our like terms, and we always should start with the highest degree, so we put it in proper order when we're done. So what's 11 plus 2? So we have 13x squared. And then what's 5 minus 7? Okay. What about C? Can you combine those? No, why not? So this is as simple as it gets. That's your answer. You cannot combine these. Okay. Look at D. What are your like terms?
None of them.
So this is kind of a trick question. Does order matter when you're multiplying? So this is xy and this is yx. Do they have the same letters? Do the letters have the same variables? Yeah, they both have ones. So these are actually like terms. So this is part of the reason we tell you all the time to make sure you put them in alphabetical order, because then when you have two terms like this, you'll know it's a lot more obvious when they're like terms. So these are actually like terms. Okay, so I'm going to just bring over that negative 9x squared. And what's 3 plus 7? So I get plus 10, and I'm going to write it properly, xy. And then I'm just going to bring over that minus 5y squared. Now, order didn't matter here because they're all the same degrees, 2, 2, 2. So you could put it in whatever order you wanted. Proper is to write them in the highest degree to lowest degree. Okay, look at E. Now we're throwing in parentheses, which tells me what? To distribute. Okay, so when I have a negative in front of parentheses, I have to distribute that negative. So negative to a positive becomes a negative. Negative to a positive becomes a negative. And a negative to a negative becomes a positive. Now, do I need that second set of parentheses? No, because it has a plus sign in front. There's no number in front, so we can just rewrite those terms in that set of parentheses. And then again, I have a third set of parentheses, and this time with a negative in front again, so I have to distribute that negative. So that gives me a negative 4x squared minus 3x, and then 2 negatives makes a positive, so plus 1. Now, what is your highest degree?
8?
No.
Oh, wait,
3. So let's start with our cubes. So I have this cubed. Is there anything else cubed? Yes, this plus 2x cubed. Anything else?
No.
No. So what's negative 8 plus 2?
9.
Oh, what did I? Don't listen to me. Y'all told me 6, and I wrote 9. Sorry. I swear I listen. I'm making up my own rules over here. Okay, now what degree comes next? The squareds. So I have this x squared, and I have a negative 4x squared. Now, if there's not a coefficient, you can always put a 1 if that makes you feel better. So what's 1 minus 4?
3.
Negative 3. So minus 3x squared. Now what? Negative x minus 3x. So that's negative 1 minus 3, which is negative 4x. And then last I have my constants. What's 3 plus 1? 4. When they get long like this, it's really easy to confuse them, which is why I go 1 degree at a time and I do something to each one so I know I used it. Does that make sense? Okay, last one. I'm going to change this problem just a tiny bit. Are you ready? We're going to put a 3 in front of that first set of parentheses. So we can distribute something other than negatives. Yes? So that's me. That number is not, like, I'm changing the problem. Yes? Okay, so what do you do when you have a number in front of your parentheses?
Distribute.
Distribute. What's 3 times 5x squared?
15x squared.
3 times negative 4x, and then 3 times 7. Now my second set, do I need that set of parentheses? Yes, because I have that negative in front. I have to distribute. 2 negatives makes a positive. Negative times a positive makes a negative. And then a negative makes a positive. So last but not least, what are my like terms? 15x squared plus 4x squared, and what does that give me? I listen this time. Next to that, what's next? And what does that give me? And lastly is my constants, 21 plus 5, which gives me 26. Any questions with that? Okay, there's 2 things on the practice I want to go over with you just as like a heads up. One of them is a problem people keep messing up on because they're overthinking it, and then another one is just to talk about vocab. On number 1 through 8, I do want you to use the vocab. I don't want you just to write a number. Okay, so like if you look at number if you look at number 5. Okay, well this is 2 terms, which means it's a binomial. And this has a degree of 1 and this has a degree of 0, which means it's linear. Now, all of the number of terms should have a word, but the degrees, some of them are going to have a number, because remember, anything 4 or more, you're just going to write the number, right? Okay. And now look at the back. Look at number 14. Okay, this is the one everybody's messed up the most. Okay, so we're just going to combine like terms. So I have an x squared y first. Do I have any more x squared y's? Yeah, I have a 10x squared y. Don't let it throw you off because it's multiple letters. Well, how many are there?
2.
1 plus 10
1.
is 11. Now, do my variables ever change? I mean, my variables or my exponents ever change? No, the only thing changing is my coefficients, yes? And when you're adding or subtracting, the only thing that should ever change are the numbers up front. Okay, so then I have xy plus xy. How many xy's did I have? 2. And then I have negative y minus 2y. So that's just the same as negative 1. So if I take 1 and I take 2 more, I took 3 y's. Does that make sense? Don't overthink it just because it has multiple letters. I had a lot of people look at that one today and just give up. And I'm like, seriously? Don't overthink it.